Good afternoon, everyone. I am Aravinda Chakravarti. I'm one of the two co-chairs, and I'm going to introduce the other. And this is the third meeting on the NASEMS committee to study genes, to study race, ethnicity, and population descriptors in genomics research. So I am a human geneticist. I should say I'm Aravinda Chakravarti, a human geneticist, NYU School of Medicine. And let me introduce Charmaine Royal, my co-chair on this committee. Charmaine.
Hello, everyone. I am Charmaine Royal, professor at Duke University. I'm a human geneticist and a bioethicist. Thanks for joining us today. Looking forward to our time together.
Thank you. So I want to begin by welcoming our committee members. We've started the hard work of not only reading the literature, but as well as listening to many experts throughout many communities so that we can assemble the final report. I want to particularly thank the speakers today who've agreed to give up their time so that they can inform all of us, as well as I acknowledge the fairly large audience I understand who are listening in on the webcast. I would hope that you would contribute to at least some of the ongoing discussion on this topic. Let me also thank the 14 institutes and the centers at the National Institutes of Health for sponsoring this study, of which the lead sponsor is the National Human Genome Research Institute, and all of you for taking the time out of your busy lives to speak with the committee. Now, before we begin, and I turn it over to the next part, to the moderator for the first session, there's a few disclaimers that I need to read for these public sessions. So first, I want to note that this is an open, on the record, information gathering session. That is, the committee is in the process of assembling the materials, as I told you, reading as well as hearing you and other experts. And then we will examine and discuss during the course of making our findings known, whatever conclusions and recommendations we may have. Therefore, I ask everyone here today to be extremely mindful of the fact that the committee has made no conclusions so far, and that it would be a mistake for anyone to leave here today that we have done so. Comments made by individuals, including members of the committee, again, should not be interpreted positions of the committee or of the academies. I already mentioned that this study is being sponsored by 14 institutes and centers and offices of the National Institutes of Health. The complete list can be found on the study's website. For those of you who may not be familiar with this committee process, this is the third of 5 planned committee meetings. Some of these meetings, such as this one, will include public sessions where we will have the opportunity to hear from many experts in the field and receive public testimony. This is all a part of the record. The committee will deliberate thoroughly before writing its draft report. Moreover, once the draft report is written, it will go through a rigorous review by other experts not connected with this committee and who are anonymous to this committee, and the committee must then respond to this review with appropriate revisions that adequately satisfy the Academy's report review committee and the chair of the National Research Council before it is considered NRC or a National Research Council's report. We expect the report will be released in early 2023. Further information on this study, including future meetings and the full statement of tasks that we were given by the National Institutes of Health, can be found on the project website. But to briefly summarize, we, the committee, have been asked to do the following: review and assess the existing methodologies, benefits, and challenges in the use of race and ethnicity and other population descriptors in genetics and genomics research. Second, to develop feasible and logical approaches to advance appropriate use of population descriptors in published genetics and genomics research study. Thus, the open session today provides an opportunity for the committee to hear from outside experts that will inform our discussions. So in the interest of time, we will not introduce all of the more than 20 committee members, but the full roster and our biographies are available on the study website. So today we will have 3 sessions. In the first, we will be looking back at how population descriptors have been used by genetics researchers working in the field and why they are used the way they are. In the second session, we will be hearing about some examples of how large-scale research programs that are extant today have used population descriptors. And after the speakers have provided remarks, we will then have time for discussion with the committee. The third and final session of today's workshop is based upon the committee's call for public comments. We have advertised the site, and a number of individuals have commented on this whole area of research as well as practice. We have asked for input relating to how population descriptors are currently being used and how they may be used in the future. And we've asked a selection of commenters to join us here today. The selection of commenters is not entirely random, but rather reflects the various classes of questions that have come up. And hopefully, without reading all of them, you will get a sense of the kind of questions that the committee will have to answer. So it is my distinct pleasure now to pass things off to Dr. John Novembre, who's a professor of genetics at the University of Chicago, and who's a member of our committee who will be moderating the first panel. So John, you could take it away.
Great, thank you, Aravinda. First, I'd like to thank our speakers for joining us today at this workshop. In this session, we'll explore the aims and requirements of genetics and genomic studies in order to better understand what types of population descriptors are needed for those studies and some of the regular challenges faced by researchers conducting these studies as they use population descriptors in their work. We'll have 15-minute presentations from each of our speakers, followed by a discussion with the committee. At that time, we'll also take questions from the audience who are joining us by webinar. So please submit your questions in the Slido box under the webinar broadcast, and I'll be presenting those to the speakers. For the sake of time, I won't be able to cover the speakers' full biographies right now, but you can read them in the briefing book, which is available in the meetings materials section of the event webpage. We have 4 great speakers coming up this session. We'll first hear from Dr. Gil McVean from the University of Oxford, followed by Dr. Akanyemi Oni-Orison from the University of California, San Francisco, then Dr. Nancy Cox of Vanderbilt University, and finally, Dr. Graham Coop of UC Davis. So with that, our first speaker today is Gil McVean, Professor of Statistical Genetics and the Director of the Big Data Institute at the University of Oxford. Gil?
Thanks, John, and I hope everyone can see my screen. So, my name is Gil McVean. I am associated with the University of Oxford. I have a background in population genetics and statistical genetics, and I'm also the Chief Scientific Officer of a company that I co-founded a number of years ago called Genomics plc. And I'm going to be talking today about the use of race, ethnicity, and ancestry as population descriptors in the development, evaluation, and application of genomically powered clinical risk models, which is a fundamental part of what the company does, but it's ultimately driven by genomic research and therefore is relevant to the committee's content. So a bit of background about the problem that we are faced with. What we are trying to do as a company is to develop clinical risk models that predict future risk of a broad range of diseases and related traits, such as response to interventions. And to do this, we combine genetic information, typically, though far from exclusively, polygenic risk scores, with other risk factors, such as age, sex, LDL cholesterol, for example, in the context of cardiovascular disease, to make quantitative statements about an individual's absolute risk over a defined time interval. And we do that because it's this type of information, the quantitative evaluation of risk, that is used within clinical care when working out what intervention to apply to a particular individual. In particular, such information can be used to identify patients who are at elevated risk of a disease and who would therefore benefit from interventions such as preventative treatment, enhanced screening, accelerated therapeutic pathways, and so on, but who are otherwise invisible to the healthcare system. That is, they don't have enough of the conventional risk factors to merit attention, but actually their genetic risk, which comes about through the substantial heritability of most common diseases, has made them at risk. So if you look on the right-hand panel here, we've got cumulative incidence curves for type 2 diabetes in the UK biobank population for individuals who self-identify as being of European ancestry and those of South Asian ancestry. The cyan line is the incidence for people with an average genetic risk. The red line is the cumulative incidence for people in the top 3% of risk. And you can see that whether you're European ancestry or South Asian ancestry, there's a huge impact of genetics on whether or not you're going to go on to get that disease, type 2 diabetes. So we work internationally, including partnerships within the US, UK, and East Asia. So a starting point is to ask how population descriptors relating to race, ethnicity, and ancestry impact our work. And briefly, there are 4 distinct areas where these are relevant. First is data harmonization. The heart of what we do is driven by an understanding of genetic impact on risk. We derive that by combining data from thousands of different genetic studies performed in different countries and cohorts and analyzed in many different ways. So population descriptors, either provided by these studies or sometimes learnt by looking at the data that derives from these, is essential metadata in understanding how studies relate to each other and what it is that they are measuring and how. The second component is in analytical optimization. What we are trying to do is to gain the best understanding of genetic risk for disease. This requires accurate modeling of relationships between study populations, those, for example, that we have data on, reference populations, for example, those such as the 1,000 genomes data sets, which provide an important understanding of what genomic variation looks like in modern humans, and the individual to whom the tool is being applied. And that 3-way relationship is critical to the optimization of our tools. The third way in which these descriptors are important is through individual baselines. Genetic risk factors can broadly be thought of as modulating an individual's baseline, that is the risk profile throughout age, which you can think of genomics or genetic factors as accelerating or deaccelerating. Now, this baseline is influenced by many factors, not just genetics, and those factors can correlate with geography as well as self-identified race and ethnicity. And then the final way in which these descriptors are important is in terms of clinical validation and evaluation, where clearly regulatory approval and clinical adoption require demonstrating performance across geographies, sexes, age ranges, and individuals who self-identify as different races or ethnicities. To give a concrete example, we published work last year on cardiovascular disease risk prediction. Here in the UK and in the US, various preventative treatments such as prescription of statins is considered within primary care and aided by calculating a 10-year risk for cardiovascular disease. Different thresholds for prevention in the different countries, but broadly similar risk factors and similar interventions are considered. What we showed last year was that we can take such conventional risk factor calculators and include polygenic risk score to improve the ability of these tools to identify individuals who go on to develop cardiovascular disease. To create the risk scores, we have combined data from many different cohorts. You can see the table on the bottom right shows you the different cohorts, something about their genetically determined ancestry and the sample sizes and the phenotypes that have gone into that. So all of these data are being combined in a way that acknowledges similarities and differences between the populations. So we take those input data and we construct a polygenic risk score that modifies these baselines. And like others, we have found that the extent to which the polygenic risk score modulates risk varies by context and many different contexts, including sex, race, ethnicity, and genetic ancestry. And there's other work which has demonstrated how age is also an important factor. However, what ultimately matters is the ability of these tools to identify people at risk and to put them on preventative treatments. One way in which you can measure the clinical benefit is by considering the net reclassification improvement, or NRI, of the integrated risk tool that combines the basic risk calculator with the genetic risk. And we have considered 3 different studies. It's worth looking at these in a little bit of detail. One is the atherosclerosis risk in communities cohort, or ARIC, which is 15,000 adults in the US, predominantly from 2 study-defined racial or ethnic groups. One is the multi-ethnic study of atherosclerosis, or MESO, which is 6,000 adults, again from the US, from 4 study-defined racial and ethnic groups. And the third is UK Biobank, which is about 500,000 adults from multiple